students, they just wait for someone else to do it, and then they just write it down, when it's up here, and then they're not practicing on their calculator. And then on quiz day, they run out of time because they weren't practicing in class. They were just sitting there waiting for someone else to do it for them. So have a calculator every day and use it. Use your calculator. Monday, 5 points. Actually, on Monday, I'm going to teach you how to input a table to the ACE Math TI 36 calculator. I'm going to teach you how to start using it well. So if you have that one, it's an advantage. If you don't, I got a cart here. You'll be doing that on Desmos. So I'm really happy I do have a Chromebook cart after all. Anyway, the students with the $20 classroom calculator are at an advantage. I want to be honest and open about that. It works better than a lot of your other calculators for the things we're doing. Your first quiz is next Thursday. So let's say you can't get the fancy calculator by Monday, maybe you can get it by Thursday, right? So make a note of that. It's written on the dartboard as well. It's chapters 1.1 to 1.3. Thursday. All right. So our first bell word. Oh, did you write the date? Did you write the assignment? Right next to the date, write your assignment. Number 1 says write MTR. This is supposed to be hanging, and I didn't realize it wasn't until this morning. So MTR, mathematical thinking and reasoning standards. We're supposed to be doing these things all the time. Like I'm supposed to have it written on my lesson plan that I've given you time to do these things. So it's pretty obvious stuff. You're supposed to be actively putting in effort. Did you know that? Dang. You've been doing it wrong. That's not fine. Okay. Now that you've read it, you'll do it. Okay. You're supposed to show problems in many different ways, multiple ways. Mathematical fluency means getting things right. Engage in discussions. Today I'm going to actually have you having discussions about math. Patterns and structures, what we've been working on the last few days for sure. Patterns and structure. You're supposed to think about, are these solutions reasonable? That's important. And then number 7, you wrote down today, apply math to real world context. The only one we've done so far is that camera photography question. So we're doing more word problems today. And today we're also using slope. It's going to feel like a review, like something you've already done. But like I said, Monday we're going to use technology to find slope for us. So we're reviewing it today, so you're ready on Monday. Here's the slope formula. That's number 2. And I'm actually going to add a number 3. Number 3 is point slope form. I'm going to use that in a problem today, so go ahead and write that down as well. It's really just slope formula taken apart, but it's useful in writing equations. So. All right, when you're done with that, get your assignment out from yesterday. Yes, this podium. It's just like the screen so high where I could put it on that. So. I'm gonna move this here in a minute. So. Yeah, we'll go. No. We're gonna go through 15 to 20 first. I know I showed those answers yesterday, but I just want to give anybody who didn't have time a chance to check. So go to page 30. Page 30. 15 to 20 on page 30. Number 20, I was pretty concerned about. I was concerned that you just 3 in. So take a look. If these were parentheses, this would be distributed in, and this would end up looking quite different. Is absolute value bar. So the 3 gets multiplied to the whole equation. It's a vertical stretch, but it ends up just landing here in front. It can't go inside, and then it gets distributed to the end. So you have a 3 kind of as a coefficient. It's a stretch, and then it also goes to the end. 3 times -1. So does anybody have any questions about how to do a stretch, vertical or horizontal? Yes. No. You can put it on the left side or the right side. I am most comfortable with it here, but all of a sudden, boom, there it is over there. Yeah, it shows up all over the place, so you can put it on the other side. Who else has a great question? All right, then let's head to that second page, which is page 15. Zoom. Zoom. Okay, here it is. So there's a lot going on here. There's a lot going on. One thing is I walked around first period, I realized that this part of the directions describe the transformation wasn't done. So I want you to do it now. You should have words describing the transformations. And even if you do have it done, like for instance, I did it here. I said up to and change slope, vertical stretch. I want you to right now use the fancy vocabulary. And I have it here. So maybe I'll talk about number 29 for a minute. A quadratic, it's -6, so I drew it down 6. Now, I'm seeing some people already using their own graph paper, and they're really enjoying it because this, you know, you run out of room quickly. I know you've seen it. So anyway, I went down 6. When I said that with words, I didn't just say down 6. I said vertical translation -6. Okay, so that word translation, I want you to practice. I'm giving you time right now to practice it. Instead of up or down, using the word vertical. The other thing that's happening in 29 is this 1/2. How do we do that? It's called a vertical shrink. And to draw it, in the regular parabola, the first point's over 1, up 1. And then the next one is over 2, up 4. Well, this is shrunk by half. So instead of over 1, up 1, you can't really tell here, I went over 1, up 1/2. It's half as high. And instead of over 2, up 4, you only go over 2, up 2. So every height is half what it was in the parent function. You can also see that here with this 4 in front. All right, so the easy part is going down 3. Boop, no problem. But how do I graph the 4? Instead of over 1, up 1, I went over 1, up 4. Because every point is 4 times as high. And that's why it's called a stretch. It's stretched up times 4. So instead of over 1, up 1, over 1, up 4. So that's called a stretch of 4. The other one's called a shrink of 1/2. So if it's greater than 1, it's stretch. If it's less than 1, it's shorten or shrink. What's another way? I cannot think of it. There's another common word for shrink. All right, who wants to talk about any more of these? What's going on? What about 27? Any questions about that one? Yeah. So, first off, are you good with the green one? Yeah. You got the green one. Start with the green one. The green one's on the handout. So, as soon as you read the word parent function, you got your handout. You're drawing the ones in the middle. It's very helpful. Now, the number at the end is the up and down. Are you good with the down? Yes. So I went down, I put a dot. Okay? The negative sign, every time there's a negative sign, there's got to be some kind of flip. So for a V shape, the negative sign in front is going to have to match it going down. So I could have gone and matched it perfectly and just put a dot going perfectly downstairs, like over one, down one, over one, down one. But the three in front affects the slope of the branches. So it's not just over one, down one, like this one, it's over one, down three. Okay? So you can actually see that here as well. The 3/4 is the new slope of the branches. I counted up 3 over 4. So the number in front is affecting the slope. Does that help at all? Yeah. Yeah. Yes. When it's not a fraction, it is easier to see it as a fraction. Yeah. So good comment.
We do number 26.
Yeah, 26. Yeah. It's funny. I actually think the regular line is more difficult. So here we are. I went up 5 dots. Okay. Up 5 dots. Now this is a -1 slope. And same thing. Kind of like what she was saying. If you want to look at it instead of a fraction, it's kind of easier to see. This slope means you're going to go down 1, right 1, down, right, and that will make that flip. It's hard to flip a straight line. So I thought about it more as slope, down 1, right 1, and that created the reflection. Yeah. Yeah, that's the parent function for the straight line. It's the parent function for the V. But the curve, as soon as you have a curve in a line, it's inconsistent. So this one is up 1 over 1. I'm sorry, should be looking at the parent function. But then the next point to make the curve is it's actually 2, 4. Because it's 2 squared. Quadratic is a number squared. So I went over 2 and 2 squared is 4. So I went up 4. The next one in the U shape is 3 squared. So I would go over 3 up 9. And then the next one is 4, 16. And then 5, 25. That's how you make a parabola. You square that. That's the base one. Yeah. Okay, who else has a good question? Everyone's benefiting from your guys' questions. It's good. We can talk about it some more. Okay, so you just think about it. I'm gonna walk around and see. I'm looking for your pictures and your words. If your words aren't there, I'm not giving you full credit. Any other graphs? Shorthand it like I did, abbreviate it. I know you write a lot. Well, baseline is to stay up to.
Also up to
Slow down and then talk about the slow. That's called a stretch.
Oh, okay. And then that'll be
Negative is our one.
okay. And then make sure you this way. Because I need to understand so like that. Nice. Yeah.
It actually is right back to, yeah. You just did it wrong.
Yeah.
It actually is right back. Both outside and right side. It's going to change the slope. Like this is called a stretch, and so instead of rise over, okay. And then this, do you have the handout? Yeah. So this one, same thing. The sides have a slope above former line. But now in this one, that's a stretch of 3. The slope would be up 3 over 1 on the sides of that U shape. Word. Word. All your numbers are over 1. I don't really know if I know what you mean. Let's say, yeah. That's a stretch. Yeah. Alright, y'all, go to page 37. Alright, what's happening on page 37? Okay. Here's our plan. We're doing page 37, letter A through C. We're gonna turn the page and do one of those, and then we're gonna do one of your problems together. All right. This says explore it. Modeling with linear functions. It says that I have to allow you to work with a partner. I could just stand up here and talk about this just right until 5 of you fall asleep, but I guess I'm not supposed to. So if you want to move, you can. Just get in a group, whatever. Just don't make it take too long. You guys talk about this. Your goal is to write an equation and understand what these words in this table is. Okay? Ready, go.
Not everybody can do the work right after school every day. My bad. I don't know if my mom would let me. I would much rather do virtual school. I will win. We're all going down lines. B is growing.
Oh yeah, it is. That's great. And then I don't know. What's your name? No, it's just oh my gosh. Oh my god. Alright, so it's Friday.
You want me to be
Whoa, guys.
I'm not good at all.
You have your equation.
Well, I know how to make it.
Start taking suggestions from the room here. So here's my graph. It says determine what type of function is in the data, and then it actually says in the very next sentence, explain how to write a linear. Oh, that's my graph. I am not happy about that. Oh man. All right. So anyway, it says right after that, it says it's a linear function. So that's why when your groups were kind of like, I have no idea what to do, I said, you know what, just find slope. Because this is linear. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, thousands, what I decided to do. I am so mad that erased. 10, 6, 7, 8, 7, 72, 65, 58, 50, 43. All right, I'm back. Years, value. All right, how did you guys figure out slope? If you did anybody figure out slope? Yeah, what'd you do? Mm-hmm. Yes, it was consistent. What? How much was it decreasing every year? Good job, you guys. Every year it's going down 7,250, and that would be the slope. So thinking about a linear function, it says explain how you could write a linear function. Well, she just explained. She's subtracting down. She noticed it's decreasing the same amount every time. So that's our m value. Can anybody explain how you would come up with the b value? Yes. 87,000, you had it. Yes, our starting value is our y-intercept. So it's starting as 87,000 and going down from there. So then that's our linear equation. So this is talking about depreciation. This is a problem that you could see in an introduction to accounting college course. Depreciation is something really important in the world of accounting. Do you guys think businesses care how much their equipment is worth? Like, if I buy this demolition robot for $87,000. In 3 years, it's still working. Do I care what it's worth? Actually, I do. I really do. I care so much that I pay an accountant $90,000 to keep track of it for me. Why would I pay an accountant to keep track of how much my robot's worth? Why would that be important? How could I use its value? Dominic? Maybe I want to sell it. Okay. Maybe in 3 years' time I want to sell it and I want to know what's a good price to sell this for. Maybe I want to buy a used robot. So I'm tracking in the economy how much I think that if someone's been using the robot for 3 years, I'm not going to pay 87 for it. How much should I pay for it? There's actual depreciation rates for different types of technology and equipment that accountants and finance people use to figure out how much they should sell and buy things for. Okay. The other thing has to do with assets and what your company is worth. A car dealership can't say to the federal government, I owe you no taxes. My company is worth nothing. There's zero in the bank. If they have 10 Ferraris in their parking lot, okay? The Ferraris are called assets, and they go into what your business is worth. The government wants to know what your assets are and what your bank account is because they're taking taxes on those things. Okay? So if I have 10 $87,000 robots, the government's keeping track of that and they want a portion of what my business is worth. So if I've been using my robots for 5 years, I'm not going to claim my robot is still worth $87,000 and have to pay taxes on that. I want to depreciate my equipment and only pay a percentage of the $65,000 that it's then worth. Okay? So all of the companies with this expensive equipment, farmers, corporate farming, factories, manufacturers, technology companies, they have somebody sitting in an office just depreciating their equipment and documenting it for the federal government, the state government. If they can't document how they spent their money or where their money is, that's when the IRS comes looking. It's like, where are you putting your money? What'd you do with this cash? What's happening? You say, oh yeah, where's my 87 grand? It's right here in this robot here. So all of those things are documented and recorded. And right here it says interpret slope and intercept. Well, intercept $87,000. That's the y-intercept. That's how much it starts. Can anybody figure out the x-intercept? X-intercept is when the robot's worth $0. When? In how many years is my robot worth $0? How long do I think this robot's gonna last? It's longer than 4 years. Oh, are you saying 4 more? Yes, 4 more years. After 12 years. Yep, you got it. 4 more years. So if you keep doing this 4 more times at year 12, it's no longer worth anything. So you could do, if you put 12 in there, it's no longer an asset. So if you have an engineer who's working on your robots and they can get that robot to work for 15 years, you then have a piece of equipment. It's an asset, but you have to claim that it's worth $0, so you don't have to pay taxes on that asset. But your engineer is keeping it working for you. So that's why you hire somebody to fix and maintain your expensive equipment. And then after 12 years, if you can tell people, hey, this still works, and then sell it, again, you're profiting there because you're not claiming any money on it. So anyway, accounting and depreciation, it's not difficult math. It's just adding and subtracting, but you get paid really well. And a lot of accountants work from home. So you should be thinking about that, you guys. Let's flip the page. Actually, a lot of accountants don't work from home, but I know some do. Some accountants travel a lot. Did you say your sister's an accountant and she works from home? Nice. Does she like it? Yeah, there you go, guys. What does she do? Yeah. Okay, there you go. All right. Okay. What time does surgery get out? 10:09. Okay, I'm skipping this. I've been talking too much. I'm actually gonna start your assignment, guys. Let's go to page 45. I'm gonna do one of those problems. So you have some steps written down. Yeah, I'm gonna do number 6. So use this problem to take notes, write steps. If there's not room in your little book, you might want to put a loose leaf notebook paper in there. Again, this is your assignment today, page 45, number 6. So I got 2 steps for you, and some of you can do this without any help from me. Please move forward at your own pace. You don't have to write my steps down. This is just so you have a systematic approach. The first thing you want to do is find slope. So I'm going to call this x1, y1, and this is x2, y2. I'm going to go ahead and do the formula. So it's negative 60. And you can think about that as over 1 or just writing the 1, not writing the 1, that's your call. From there, I want to write an equation. I'm going to use point slope form. And that's the second one I had you write down in bell work. So I guess I'll do y minus 300 equals negative 60. That's the m value I just found, x minus 3. I will simplify this using the distributive property. And then I just have to bring this 300 over. Hopefully this is feeling much more familiar to you than maybe yesterday's assignment. And there's my equation. Now, I need to assess the reasonableness of what I just came up with. So when I look at my line, my B value should line up. So yeah, my line goes almost to 500. If I was just looking at it and guessing, maybe I would have guessed 490, but I did the math and now I know it's exactly 480. So that formula helped me come up with that exact y-intercept of 480. So that's part 1. Part 2 is really important. It's on your quiz even. It says that you have to interpret the slope. And I'm really particular about how you do that. When the directions say interpret the slope or even interpret the intercepts, that means use words to specifically describe what's happening. So an answer of the line goes down 60 over 1 is not going to cut it. We're looking for specific words. I want to hear about the swimming pool. I want to hear about the y-axis, the volume, and the time. Very specific description. So an example is the pool's volume is decreasing 60 cubic feet each hour. Okay, so when it says interpret slope, we're talking a very specific proof that you understand what that negative 60 represents. So that's it. That's your assignment. You have 4 minutes to do. Keep working. Please don't pack up early. There's 3 of these that you're doing on your own. It was numbers 1, 4, 6, and 7.